Okay, then we will start.
Yeah, okay.
Yes. So actually, I have not made much changes from the last year slide because last week's our slide. Uh, this was the agenda for last time, but last time we discussed so much on the recap only. So we were not able to see this base theorem and the discrete probability distribution. So today we will just again we'll look at the conditional probability. Can you recall the how we are calculating the conditional probability? How to calculate the probability A given B?
Yeah, means probability of A given B is equal to, like, base theorem I have to tell.
No, probability, conditional probability. Event B has happened. What is the probability that event A will happen? For your just draw a diagram. There are two events. Event A,
Mutually exclusive.
event A. You see the diagram, then you will understand. Event B. I'm asking what is the probability of A given B?
But yeah, diagram is not visible.
Above my head, recap, nearby recap.
No, it's not visible.
Now, hello.
No, I'm not able to see.
I will just disconnect and get back here. Now, are you able to see me? The diagram? Nearby the recap, this
Mm.
part and this part.
Yeah, yeah, yeah. Okay, okay.
So this is my event A, this is my event B, this is my sample space. The event B has already happened. This is what I know. Now I'm asking what is the probability that event A will also happen? That is this part upon this whole part. Correct? Because now the sample space
Yeah.
will reduce. Already these are not going to happen everywhere here. The black part is not going to happen at all. Only you know that this circle, B circle only going to happen, but there is some part which is shared by the event A. So that is A intersection B upon B. And so we are calculating probability. That's why we calculate probability of A intersection B above probability of B. For example, we last time saw that there are four uh, students from Maharashtra, two girls, two boys. Four students from West Bengal, two girls, two boys. Okay. So now I told you that I have selected randomly a person. A person I have selected from TDA. Am I audible?
Yeah, yeah.
And I hope that the screen is also visible.
Yeah, screen is also visible.
So there are four students from Maharashtra, two girls and two boys. There are four students from West Bengal, two girls and two boys. Now I have randomly selected a person or student and I come to know that the person is from West Bengal.
Hmm.
Just a minute. Having some. My laptop is not able to bear me. I don't know why. Because I'm running so many programs at a time. Just give me a minute.
Okay, भैया.
Okay. So you until then you can calculate that the person is selected randomly. He is from West Bengal. Now, what is the probability that person will be male? Calculate that. You got my question?
हाँ जी.
You can give a try.
भैया, in intersection we have to add.
See, intersection is, if I say and, I need to say that it is multiplication. So intersection is and
Oh.
or it's addition. You don't calculate using the formula. You calculate by your intuition first. Then we will plug it into formula, because that is what the confusing part here.
Um.
Sajjad, just 1 minute. I'm just leaving this
Zero.
meeting. I'll return back. Okay.
Okay.
Okay. Okay. I think there is no need. Okay. Now, am I visible properly? Just right here.
हाँ जी.
Okay. 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 So see, we will have you calculated anything?
Uh, is it 1/4?
Just a minute. I also need to calculate. Okay, you have calculated this 1/4. I will write here for you. It is 1/4. This is what you have calculated. Now we will look at that also. How many total students are there?
8.
8. So I would say there are total. This is my sample space. There are total 8 students are there, right? Now I am defining. See how I am defining. I want the state also. I want the male female also. So
Male.
now, yes. So now my state events will be mutually exclusive, or they will be not mutually exclusive. What you say?
Mutually exclusive. Right.
Yes. So now you have got the idea that states will be mutually exclusive. They will not intersect anywhere. This will be for EM. This will be for W, West Bengal. But now our gender events will be what? Mutually exclusive?
They will not be. No.
No, they will also be mutually exclusive. If I draw only gender, two gender, then they will be mutually exclusive. But so if I draw like this, so actually this is going to be like this part. Actually, if I draw neat and correct diagram, it should be like this. This part below this, it is male, above it is female. This part, half part, it is Maharashtra and West Bengal. So this is what we have also drawn, na? Isn't it?
Yeah.
So now
Yes.
female from Maharashtra 2, female from West Bengal 2, male from Maharashtra 2, female from Maharashtra, male from West Bengal 2. This is what. So now what we are saying that we know that already event. Now for your learning we will consider this diagram. Here are 2, 2, 2 and 2. Now already event A has happened. So already I know that West Bengal has been chosen. So already I know. Now my sample space reduced to 4. Correct? Previously it was 8
4.
students total.
Yeah.
Now I already know that it has been selected. So it is 4. What is this 4? This is probability of B. A given B. What is my question?
Yes.
Probability that male given West Bengal. So that is my B. So this is my B here. So it becomes now probability of West Bengal, which is 4 by 8. Correct? What is now
Yes.
intersection? What is intersection? This is the part intersection. Correct? Male and West Bengal. What is the probability of that
West Bengal.
section? What is the probability of that section? It is
2 by 4.
not 4. See, this is event. I am talking only on respect to TDA itself. Talking to respect to this one, it is 2 by 8. So 2 by 8 divided by 4 by 8. So it is 1 by 2. So even we don't know this formula, how to plug it. So simply I know that West Bengal already selected. So what becomes West Bengal? So total 4 students. What is the probability that male will get selected? 2. So it is 1 by 2. But when formula you are putting, when you are putting this formula, probability of A intersection B, so it is always in reference with sample space. Okay?
Okay.
So now this is our third time we are clearing this concept, but yes, you will eventually understand and clear this idea. Now because we have practiced so many times. Okay. Yes, just delete me. Now you tell me what is the law of total probability.
For law of total probability, there should be means there are some conditions like conditional probability should be there. Events should be collectively absorptive. And then events should be mutually exclusive too.
Yes, so you are sitting it right. I don't know whether what are the requirements. Can be theoretically we can explain. Let it be what you have said. That only I will explain again. So now, when I am having the sample space, this is first you said, and I have some mutually exclusive events. Mutually exclusive events means this is my circle, this is my circle, this is my circle, this is my. But like these kinds of event, I don't want. What I want the event which will be mutually exclusive, but also what they will do, they will partition my sample space. And we said that they will be what is the don't see my spelling.
Collectively absorptive.
Exhaustive. Okay. Collectively exhaustive means it should finish. If you see how many events there should be, 4, 5, 6, we don't know how many, but it should be finite. It should not be infinite events. I given last time example, if you remember, what is the income? For the income, you can say 1, 2, 3, 4, 5, or you can go on and go on, stop, because there people will be having more and more and more on income. So, but if I say the question for me, the question is that what is or how many colors in rainbow? Okay, so this kind of question only have 7 answers which can be given. Okay, so these kinds of events I need. What is another? Then I'm having another event which is intersecting these all events. Then how to calculate the probability of that event is given by law of total probability. What is law of total probability? Welcome. You can also join our hands. What is the law of total probability? If you know, you can explain. Suppose these events are A, B, C, and D. In that case, and this is my event F. So the probability of F is given as the probability of F given A plus probability of F given B plus probability of F given C plus probability of F given D. Got my point? Because this is the event I am asking that. So now last example, if you see, I have just increased the number of states. Are you getting my point? So these are states of Maharashtra, Karnataka, whatever. So there can be at max how many? 29 will be there. So in that case, I'm asking that in TDA there are students from these 4 states, and there are girls from all the states. I know how many girls are there from Maharashtra, how many girls from Karnataka, how many girls from West Bengal, how many girls from Jharkhand or anything, Madhya Pradesh or Bihar. Now I want to know that what is the probability that if I randomly select a person, that person will be female. For that, what is the probability? I need to calculate probability of A given B, F given B, F given B, F given C, F given D. So that will give me collectively number of girls, and in this case it will give the probability that the selected person is female. Got my point?
Yeah, Bhaiya, these A, B, C, D are number of girls or number of total students?
No.
Means
See,
number.
A, B, C, D are, this is, I will explain again. See, right side of the recap, you see another diagram. Okay. Here I am drawing another diagram. I will explain. You can remember these as examples. Whenever someone is calling you what is law of probability, you should remember this diagram. No need to remember this formula. If you remember this diagram, in case of conditional probability, one diagram I will draw here. These 2 diagrams you need to remember. So in case of law of total probability, see, these are the states. Now in your batch, students from how many students there are, from how many states students are there?
5, I think 5 or 6.
5. So okay, let it be 5. So there are total 5. This is the situation of TDA, correct? Or your PDM something 23 or some XYZ. Okay. So this is the condition. There are only 5 possible options if I ask their states, correct? They are finite.
Yeah.
They are mutually exclusive. So this is my A, B, C, D are states. And then I am asking how many total number of girls in TDA. I'm not asking about from Maharashtra. I'm not asking Karnataka. I want collectively, I want to know that if I select a person randomly, whether she is from Karnataka or Maharashtra or West Bengal, I don't care. What I care is that whether she is male or whether she is female or not. In that case, I want to know that this data, that is good thing, because many a times what will happen, you will know this part, 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 but you don't know what is the total number of girls. Suppose there is departments, different departments for different states in TDA. They don't know that what is happening in another department. In that case, they only know that within my department or my state, how many girls are there. Within my state, how many girls are there. Within my state, how many girls. So someone needs to collect that and put together. So if I ask that what is the probability that if I get girl, so this is what the probability I will get, and that I can calculate using this formula. That this is suppose event A, this is suppose event F. So probability of F given A, F given B, F given C, F given D, F given E. In your case, you can relate like this. Female given from Maharashtra. Female given that I have selected student from Karnataka. Female given that I have selected from Madhya Pradesh or Bihar or Jharkhand. Somewhere. Got my point? This is law of total probability. You got? Understood?
Yes.
Amit, is
Yes.
it clear?
हाँ भैया yes.
Yes. So now you just remember this another diagram I'm drawing multiple times. You just remember these are two events A and B. What is the probability that event A will happen given that event B has already happened? And this is the diagram you need to remember. B already happened. So I need to just calculate A intersection B with respect to my sample space. So it is given by probability of A intersection B divided by probability of B, okay, is equal to probability of A given B. Simple.
B.
Clear?
हाँ जी.
This is what the example we have solved last week. Now you can solve this week. By your own, I will give you 2 minutes only because you already have solved last week. Here we have discussed a lot, I think 8 minutes or so last session. Okay, problem is that in a village there are 60% of males, there are 40% of females. Okay, it should be the same. And then there are 50% males are addicted and 30% of females are addicted. Okay. If I randomly select a person from that village, what is the probability that he or she is addicted? I'm not asking about male, not asking about female. I don't know how many percent people are addicted in that village. Calculate that using the law of total probability. This is the hint for you. Got answer?
भैया 0.42.
Amit, are you trying?
हाँ yes भैया.
Take 1 more minute, please. We need, because we are, this is now 2.5 weeks. We are in same situation because we also not spend giving more important for speed. Let it be. Done?
Bhaiya, I'm trying to continue.
Hmm?
Maybe it will take time.
Okay, so you can solve it as a exercise. Now you can see, you leave it. Now I will solve it. You just see that how I am solving it. Okay. So now we know that this is what my diagram will be understanding is that here are total. This is my sample space. If I divide it as male female, there are 60%. So we can assume that there are 100 uh, people are there. So out of that 60 are male, 40 are female. This is what my partition, first partition. Then second partition is that whether it is addicted or not. Out of this 30% are addicted. So this is 30. Out of this the total 30% are addicted. Sorry, this is 50% are addicted. So this is 30. And out of this 30% are addicted, which is 12 if I am not wrong. Yes. So now I have been asked that if a person randomly select from that village, what is the probability that he or she is addicted? How I can going to calculate? So that will be probability of addicted will be probability of addicted given he or she is male plus
Male.
probability of addicted given he or she is female. So what is probability of
Female.
A? Probability of A given M means addicted given me is equal to probability of A intersection M divided by probability of M plus probability of A intersection F, which is addicted given female, divided by probability of female. Okay. So what is probability of male and what is probability of female? That we know. So I'm coming here because maybe my photo will be there. Probability of A is equal to, what is probability of AM? It is 60 upon 100. Correct? This is. What is probability of A intersection B? This is 30 upon 100. Right? This part. Plus 12 divided by 100 upon 40 divided by 100. Right? Right? Are you getting how these values are arrived? Just give me yes or no.
Yes.
Yes. So now we will do simplify. It will be 30 divided by 60 and 12 divided by, it will be 1 divided by 2 plus 12 divided by 40. So it will go 6 divided by 20. 1 3 is 3.2 somewhere around it will come. So you can do this calculation part, but I think that it should be greater than 50. Okay. It should be greater than 50 if we do the calculations on this basis. It's fine. Or Sajal, are you having some doubts?
Okay, भैया.
Hmm? Yes, as an exercise, you can even solve it later also. Now we will come to the Bayes theorem. We have seen the conditional probability. We have seen the law of total probability. Now we will move into the Bayes theorem. Okay. No need to remember the conditional probability. No need to remember the law of total probability. You need to remember the concept. You can go and search anytime on the internet. You will get this formula. So I also don't remember this. But now I want to interestingly tell you that how this formula has been arrived. We will see that what is the conditional probability formula, because just now we have given, if I ask you probability of A given B, this is what we are calculating, isn't it? In Bayes theorem also. What is the formula of A given B? Just now we have seen.
Yeah, probability of A intersection B divided by probability of B.
Okay, as your the second part should come below, this both should come above. Okay, but here the formula is seeing little bit different, isn't it? Yeah, they are something multiplying by probability of A, then divided by probability of B, and then they are giving probability of B given A. What is this going on, isn't it? Okay, so we will see that how this formula they have just changed. So now one wise person like you and Amit or Sajal, Amit, Priya or Akshay, what they have did, he saw this formula and do some algebraic manipulation. What he have did, he brought this part to this part. What will happen? Here it is dividing. After coming here, what will happen?
Multiply.
Multiply. So probability of B into probability of A given B is equal to probability of A intersection B. Okay, this is the one
Yes.
wise part they have did. Now they have did another wise part. If you see the diagram which we have uh, drawing for last multiple times for conditional probability. This is event A, this is event B, this is event A intersection, isn't it?
Yes.
So this part, the probability of A intersection B, what he has thought, so what is the probability that B given A, that is also going to be same. Why? Because these two events are interacting at the same time. So this is the part is only going to happen if either A event has happened or B event has happened. Are you getting this?
No, Bhaiya.
No. Yes. So now we have been seeing the example that there are so I need to take like this. This is the event I'm taking from dice. Okay. So this is the event, the sample space. You know that it is my, what is sample space for rolling a die?
6.
6.
Yes. 4 to 5, 1, 2, 4, 5, 6. This is my event. And what you are saying, just 6, it is the cardinality of that sample space. What is the cardinality of set? You can search on the internet. Okay. So now I have defined two events on this sample space. My first event is that the outcome is an even number. Okay, this is my event, even number. What is going to be inside this event? What are the favorable outcomes from this 1, 2, 3, 4, 5, 6 even number? What will come here?
2 by 6, 4 by 6.
2. No, why 6? That is probability. Yeah? I'm just asking about the outcomes. So 2, 4 and 6. If I ask the probability, that what is the probability that even event A will happen, then you can do this dividation part. So now I am also defining another event, that the event is dividable, the outcome is dividable by 3. So what will be the favorable outcomes? 3 and 6. So I will draw another sample then circle here. It is coming 3 and 6. Are you able to see this diagram here?
Yes.
Yes.
Yes. So it is 2, 4, 6, 3. What is remaining? 1 and 5. So that will be here 1 and 5. Correct? This is what visualization part. This is my event B. Can you tell me what is my event A and what is my event B?
Event A 2, 4 and 6. Event B 6 and 3.
Yes,
Means
but this is what
in
you have given the values in the name, in the words. I need to tell that. What condition I told you for event A?
even
Event,
na even
event A. Event A means outcome should be even.
Even.
Then uh, it should be divisible. Second B is it should be divisible by 3.
3. Yes. So it is divisible by 3. Okay. So now you are clear. That why I asked that you are clear about the events. Now I am asking you that what is the probability that event A will occur given that event B has already happened? How you are going to calculate that? It is equal to probability of A intersection B
Intersection B
divided by probability of
divided by
B.
probability of B.
What is the divided probability of B? It is 2 by 6. What is probability of A intersection B? It is 1 by 6. Right? Correct?
How by I can't get this one.
No. What is the probability that event B has already happened?
Okay.
B has already happened.
2 by 6.
B is 2 by 6. Now I am asking event B has happened. I will just change the color so that as this event has already happened, I know that. What is the probability that event A also will happen? When event A will happen, either if outcome is 2, 4 and 6. Correct?
Okay.
When it is going to happen? Only if the die my rolls to the 6. Isn't it?
Yeah, means at that time both will happen. Yeah, correct.
Correct? So that is what is the probability of that condition? That is what we are
1 by
calculating.
6.
So yes. So it should come not it's not 1 by 6. It is 1 by 2 only. Because event B has already happened. Na? Now if I ask differently that what is the probability of event B will happen given that A has happened? How it will change?
1 by 3.
Yes. So now it will change to the 1 by 3. Why it will be 1 by 3? Because it will be 1 by 6 divided by the 2 by 6 will become 3 by 6. It's 1 by 2. Or we will say 3 by 6. So this 6 will cancel out. 1 by 3 will remain. Right? Are you getting my point? Amit, clear?
हाँ भैया.
Yes. So now what they have said that if I multiple that event with my probability of A already, then I will get my event A intersection B. This is what here we are calculating. Probability of, suppose I want the probability of A intersection B. So now probability of, only just see the formulas, okay? Probability of B given A would be probability of B intersection A into probability of A. So now what is the probability? We have calculated this much, correct? This is 1 by 2 and 1 by 3. Now we will just see that what is my 1 by 2? Probability of A given B is equal to B given A is equal to 1 by 2. Probability of A given B is equal to 1 by 3. Don't forget what is A, what is B. It is getting complicated, isn't it? So I will just repeat you again. See, what was my event? Event A is my event. Numbers are even. What is event B? It was divisible by 3.
3.
So that we have calculated that event B, that divisible 3 has already happened. Then what is the probability of event A will happen? It is only 1 by 2. Okay, probability of A given that B has happened is 1 by 2. Probability might not be visible here, so I will write here again. Probability of event A. What is event A? Even number. Given that already I have diced the number divisible by 3 is equal to only 1 by 2. Now what is probability of event B given that A? So already I know that number is even. What is the probability that it will be also divisible by 3, which we calculated 1 by 3. Now we will just see the magic. What is the probability of event A alone? What is my probability? What is the probability of event A alone? It is 3 by 6. What is the probability of my event? Sorry. Here I should. What is the probability of event B? It is 2 by 6. What is the probability of event A? It is 3 by 6. And if you multiply this both, you will get the same answer as a 1 by 2 into, so this 2 will get cancelled, this 3 will get cancelled, is equal to 1 by 6. Are you clear? Tell me no, because I'm going to repeat this. Are you clear?
Actually, there was an issue in the village, so they were calling me. I didn't pay attention here.
Okay, no problem. I'm going to just explain again that how this has happened. There is no need actually how it has been arrived. But if you know that, na, you need not to remember the formulas. For lifetime, you will just get the understanding. So you will not worry about the formulas. That's why I'm explaining this much. Okay, just forget the title. We will go through the problem statement. What we are saying, I will tell you that. We are saying probability of event A into, just we'll say probability of event A into probability of B given A. See what I'm saying? Probability of A into probability of B given A is equal to probability of B into probability of A given B. This is what we want to prove. Why we want to prove? Because see, probability of A into probability of A given B is equal to A intersection B. This is what we are saying, is equal to B intersection A. This is what we want to prove. Why we want to prove that? If you come here, we are using this formula to replace the dependency of one event, which is the event A itself. A intersection B, if I don't know, I'm removing that dependency. Why we need to remove that, and that's all, you don't remember. Okay, so what we are doing, that's what I'm saying there. Probability of A into probability of B given A. This is what true, this is what we are trying to prove. Okay, got my point? Until here you are clear?
Yeah, okay.
Now we will take the same example which we have solved earlier, so that you will get idea that how these things are going to be equal. With example, you can able to imagine that. So this is what we talk. The first event we have taken, which is event is even number, correct? My outcome of dice, I will write here the outcomes for better 1, 2, 3, 4, 5 and 6. These are the my outcomes. This is equal to my sample space. Okay, what I said, first event I described or defined on my sample space, that is my number is even number. Now I'm defining another event that the whatever number I will die, it will be divisible by 3. So this is what my another event. And favorable outcomes, there are some two outcomes, the 1 and 5. if one rolls, none of my event is going to happen, correct?
Correct.
If I roll 5, if I roll a dice, it shows the 5. Then neither event A has happened because it is not even number. Neither event B has happened because it is not divisible by 3.
3.
So I'm saying this 1 and 5 as a freely. This completes my sample space, understanding of my sample space. Got my idea? Until here, are you with me?
Yes.
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 Oh. यहाँ तक बहुत सीधा साधा हो गया हमारा. Now we will do some questions. Now what we will do, just change me the color. We will calculate this part and this part to check that whatever we are saying here, that probability of A into probability of B given A and probability of B into probability of A given B are equal. This is what we are checking. This is the rule. But we are checking this rule, whether it is correct or not. Okay? So we will calculate what is the probability of A given B. So probability of A given B, here we will first calculate probability of A given B, which is equal to probability of A intersection B divided by probability of B. Correct? What is my event A? It is even number. What is my B? It is divisible by 3. Now in my sample space, if you check 1, 2, 3, 4, 5, how many numbers are there which follow this both? Even also, divisible by 3 also. How many numbers are there? Only one number.
1.
That's why my probability of A intersection B is 1 by 6. What is probability of B? My B event is divisible by 3. How many values are there? Favorable outcomes? 2. So my probability of B becomes 2 by 6. You might get confused. That's why I will do this manually multiplication, which we do that if we are dividing by a fraction, then we will do the inverse multiplication. So 1 by 6 into 2 by 6. Oh, sorry, 6 by 2. This is the inverse multiplication. This is what we are solving. How you got 1 by 2. So this 6 will get cancelled with this 6 and we will get is equal to 1 by 2. So we got probability of A given B 1 by 2, correct? This part up to here clear?
Yes.
So one portion we have calculated, that is 1 by 2. This is what we have calculated. Now I will just erase this so that we will get some more space for the, oh my god, for my second calculation, which is B given A. I don't know about the event A has happened or not. Now I want to calculate what is the probability, that probability B. It was earlier is what? A given B. Now I am calculating B given A. What is probability of B given A? Now, what is B? B is my divisible by 3. 3 and 6, correct? This 2, this part. And what is my A? It is even number. How many favorable outcomes are there which follows this? It is divisible by 3 also and even also. Only one outcome, which is 6. So my probability of A intersection B divided by probability of A. This is what is formula, probability of B given A, correct?
Yeah. Yes.
Correct. Because this second A will come into the denominator and this intersection will come in numerator. So I will put the values. Probability of A intersection B is equal to 1 by 6 divided by probability of A. What is my event A? It is my this event, which is even number. What is the probability of my this event? Even number will happen. It is,
3 by 6
yes.
means 1 by 2.
No, we will keep 3 by 6 because now we want to cancel it out. So we will do is equal to 1 by 6 into inverse multiplication. As we are dividing by fraction, we'll do 6 by
6
3,
by
which is equal to 1 by 3. Correct?
Yes.
So now we got another problem answer. Probability of B given A is, I will write below, 1 by 3. So earlier we got probability of A given B, it is 1 by 2. Now we got probability of B given A, it is 1 by 3. What is probability of A and what is probability of B? What is probability of A? Just now we calculated. Probability of A is even number. What is that?
1 by 2. 3 by 6 is equal to 1 by 2.
1 by 2 we will take. What is probability of event B? This event. नीचे वाला.
1 by 3.
Okay, 2 by 6 means 1 by 3. Now if we do the multiplication, what I am getting? 1 by 3, because we got all 4 values. यहाँ के दोनों मिल गए, यहाँ के दोनों मिल गए. अब मल्टीप्लिकेशन कर देंगे. ये नीचे का है, मैं इरेज कर देता हूँ. So that we will do calculations here. So now we will get 1 by 2 into 1 by 3 is equal to 1 by 6. This is my left hand side, is equal to, what is my right hand side? 1 by 3 into 1 by 2, which is equal to 1 by 6. My left hand side and my right hand side are equal. That's why I am saying that this is true. Got? You got my point?
Yes.
This is what exactly has been used. And we saw earlier, this is equal to A intersection B, probability of A intersection B. 1 by 6. Correct? A intersection B is my 6, which is 1 by 6. Yeah. This is my probability of
6.
A intersection B, 1 by 6. So this equals to 1 A intersection B. Until here, are you clear?
Yes.
This is what one wise person had saw. He did some calculations like we are doing now. He calculated some events. And he saw that whatever we do, whether we calculate probability of A into probability of B given A, or probability of B into probability of A given B, both are coming equal. Now he said, okay, then I can change the formula of conditional probability into the different way. So what he did, I will just erase this point because this is what we were doing a whole lot of time. Okay. So what he has observed, two things he has observed. First thing, I will write it, enumerate it, because you will get understanding visually better. Probability of our earlier formula of probability of A given B, what it was, is equal to probability of A intersection B divided by probability of B. What he did, he derived the second formula. Based on that, he said that probability of A intersection B, I just take this to this side and brought this to this side, is equal to probability of B into probability of A given B. And we just saw here, this is what he is saying, is equal to this part, is equal to this part. Then another person came, what he said that he saw third, that probability of B into probability of A given B is also equal to probability of A into probability of B given A. Until here clear?
Hanji.
Okay. So now he took the earlier our formula of conditional probability. Now what is problem here? Here you are mandatory to know that what is the probability of A intersection B. Right? See, when you are doing dice problem, it is very simple problem. You can do in your hand, right? You can visualize. Now when I'm doing it field, what I'm saying that what is the probability that he is male and also addicted? To know this, it's very difficult to find. But someone has did study that how many males are there, demographic data is available. Someone has did study that what is the probability of addicted, that is available. Okay, and if someone goes and sees the only the output, not the process, means what? I will take care. Someone asks you, now what I was asking, probability of A given B. Now someone if asks you what is probability that B given A, first I was saying that what is probability that the person is from Maharashtra. I have got about what is probability that he or she will be female. This is what we saw the first problem, correct? Now what if I
Yes.
don't know how many students are from Maharashtra, or earlier what I know something, but someone asked me what is the probability that I will get female if I selected a person who is female. Now what is probability that he or she will be from Maharashtra? This is inverse question. Earlier we calculated only probability of female with law of total probability. Now he is asking me another question. I have selected a person which is female. Now I want to know that what is probability that she will be from Maharashtra. This is the problem which is solved by the Bayes theorem. Okay, so here what we are doing, we are just doing this formula and this substituting the values of this formula. So what we did, probability of A given B is equal to what is probability of A intersection B, that is probability of B into probability of A given B. But what is probability of B? So the formula will become, we'll go step by step, probability of, for this sequence I will write in this sequence, it is not problematic whatever you write first or second. Probability of A given B into probability of B divided by probability of B. Is it correct? Is it correct?
Yes, yes, correct.
Correct, because this is what we have calculated for 3 times. Now what is the problem here? I am calculating probability of A given B. In that answer itself I am asking what is probability of A given B. So this is never ending process. If I expand this formula, you can try in your notebook because here I am in limited time. So what will be this expansion? Again, probability of A given B, I will do this part. Again and again and again. I will not stop here. Correct?
Hmm.
Are you getting my point? What is the problem here? This term is problem. Because it is like, what is the price of mango? In this question itself, I am asking what is the price of mango? The price of mango is equal to
Yes, yes.
price of mango divided by 1. Is it making sense? No, because I am asking what is
No.
price of mango itself. Then you can say that price of mango is equal to price of orange divided by 2. That is fairly okay because that is two are different variables. Here I am saying that price of mango is equal to price of mango divided by 1. That doesn't help us to solve get the really answer. So the another genius person who found out that inverse, that this is actually is equal to this. Now I don't need this because I'll just write the same ink and with larger, that I replace this probability of A given B with this part probability of, that is what they have did here. This part is coming here, this part is already here, this is the, got my point? What is Bayes theorem?
Yeah, understood, Bhaiya.
I'm telling you again and again. See, now you might be looking at why the hell I'm doing this. I'm just, no, I know what is A intersection B. आप दोनों इवेंट भी दे दो, इवेंट ए दिया तभी भी मुझे कैलकुलेट करना आ रहा है, इवेंट बी दिया तभी भी मुझे कैलकुलेट आ रहा है. अभी आप क्या करने वाले हो? ये इतना ए और बी और ए करके क्या मिलेगा? See, so this had some practical implications when it comes to the practical problems. Like I will give you the example. The company is having two suppliers. Okay. Or in the village, there are two suppliers of the fertilizer. Both people are selling. Only two shops are there. They are selling the fertilizers. You are doing research or development work on the agriculture. There are two fertilizer shops. I know the fertilizer shop one, which is selling the company X product, fertilizer shop 2, which is selling the company Y product, same product like urea. The company X product, because of market study, I know that it is 95%, it is defective. So if I purchase 100 gunny bags of urea, 95 are okay, 5 are problematic. Okay. Another person who is having same company, another company, which is Y company, there it is 98%. So that if I purchase gunny bags from the second shop, I will get that it is 2%. So only 2 gunny bags are bad. This is what I know. Correct? Because this is open data. Now what has happened? Farmer, we have purchased from both of the gunny bags, because here he was available only 100 bags. Here also he was having 100 bags. But we require to distribute to the farmer, we require 200 bags. So we purchased 100 bags from shop 1, 100 bags from shop 2, and we distributed it into the farmers. Now farmers complained you that the urea which I used in my farm got problematic. Something bad happened. So it has inversely affected to its crop or yield or something. Now you want to know that which bag, either this bag was from shop 1 or shop 2. This is the problem we are going to solve with Bayes theorem. Why we are not able to solve this problem using the conditional probability? What is my event A in this case? That it is from shop 1. Correct? What is my second event? B. It is defective. But I don't know A intersection B, whether it is really coming from this shop or that shop. This A intersection B in conditional probability, I don't know. In that case, we can use the Bayes theorem. Got my point?
Yes, Bhaiya.
So why we are doing this? So we have spent around 2 weeks to understand the Bayes theorem. I will just tell you the one interesting part. That now I am studying in IIT Madras, which is based in programming and data science, and now I'm about to complete my diploma in data science. Still I am learning the Bayes theorem again. Okay, but with now practical examples with Python implementation, how this in reality is affecting. So Bayes theorem is very fundamental. If you are doing something interesting or research part, something and in field, this is going to help you so much. So that if you know that how it is coming, how we are arriving up to the Bayes theorem, it's very easy to do all this part. It's okay?
Okay.
So now here is a problem, and we have finished our time. Okay. So maybe you can take this as a take home. Okay, we will try to solve here. So now you can write it down on your paper. Please write this formula, because I'm now going to the next slide, so you will not be able to see this formula. So you please make a note of it. Probability of A given B is equal to probability of B given A into probability of A divided by the probability of B. Written?
Noted.
Noted. Yes. Now we will go to the problem. So now that formula we are going to use. This will not happen in reality. This will not happen in practice because there we don't know whether we need to use Bayes theorem or we need to use conditional probability or we need to use law of total probability. That you need to understand based on the events. Like here in this example, I immediately defined the events like from it is sharp, it is defective. This is what the practice to your mind should come, and when you do more and more and more problems, this practice will come to your automatically to your mind that this is event A, this is event B, this has happened, what is going to happen. So in that case you should not think that, oh, what is event A is even, so it is 2 3 4, then what is event B, event B is divisible by 3, then it is 6. This will take too much time. So once you do the practice you will get familiar with it. Now here everything has been given. So this is what I learned Bayes theorem from this example in along 2 years back from one of my course in Statistics for Data Science 2 course. And I liked so much that this example was here you need not to do anything first of all, that it is available for you, just you need to plug the values. So now here it is given problem. We have earn 1 and earn 2. We have two pots. Earn means pot. So earn 1, earn 2. And we are going to randomly pick a marble. First, we are going to pick the earn 1 or 2. So you are having option 2 earns. You can select from this or that. So in that case, you are going to select one earn. Then in that one earn, you are going to select a marble. There are some odd number of marbles. So I think here are 1, 2, 3, 4, 5, 6, 7 red and 6 blue marbles are there. This is what they have given. Even they have calculated what is the probability of red given earn 1. Okay. What is probability of red? It is 1, 2, 3, 4, 5, 6, 7 upon 13. What is the probability of red given it is earned 2? So earned 2 has been given already. The sample space come down to 13 and there are only 5 red marbles. So it is 5 by 13. 1, 2, 3, 4, 5. What is the probability of blue given earn 1? It is 6 blue marbles are there and earn 1 has 13 total marbles. So it is 6 given 13. What is from blue given earn 2? So there are 1, 2, 3, 4, 5, 6, 7, 8. So it is 8 by 13. Clear?
Yes.
Now we have asked what is the probability of, given that I got the red marble, it is from earn 1. Randomly someone has picked, I was not present. At that time Amit went and picked a marble and it is red marble. Amit showed me, I got bhaiya red marble. I said, okay, nice. Now I got problem whether it is from earn 1 or earn 2, because from earn 1 I am having price of rupees 500, for earn 2 suppose 200 only. So I want to know that if it is from earn 1 then I will give him price. If it's from earn 2 I will give some only 200 rupees. So I want to know, but I have not seen that from which pot the Amit has picked up the marble. So I'm going to calculate with probability. I'm going to guess it from which earn he might have picked. If it is more probability on earn 1, then I will give him 500 rupees. If it is more probability on earn 2, then I will give him 200 rupees. Okay. So what is the probability that earn 1 given that red marble has come? So we will plot our formula. You have noted it down. So better you write it like I am writing here. Probability of earn 1 given that it is red is equal to, what is our formula? Probability of, I also forgot, B given A into probability of,
Probability of B.
so probability of B, what is my B here? Red. Red given A, which is earn 1,
And 1.
into what is my second? Probability of A. What is my A here? It is earn 1. So probability of earn 1 divided by probability of what is my B here? It is red. Correct?
Hanji.
So now we can just plug these values here and we can get the answer, which is equal to probability of red given earn 1. What is the red given earn 1? It is 7 by 13 into probability of earn 1. What is probability of getting earn 1? It is 1 by 2 divided by
2.
probability of red. What is the probability of red? Here we are getting problem, isn't it? How to find the probability of red?
13 by 26 means 1
No, this
by
is what
2.
you are counting now. Okay, because you know this, here are this much, here are this much, so I will calculate. That is not my point. What I am saying that if you don't know, in this case we have seen some theories or formulas ahead which you can use it here very appropriately, and that's why we have learned it before the Bayes theorem.
Axioms.
Axioms are probability axioms. We have seen the formula. Or something like this. Have you seen the law of total probability?
Yes, Bhaiya.
This
Yes,
is
yes.
what is the statistics. Not knowing that how to calculate. Now I know that law of total probability, I can go back, I can see that what is the law of total probability, I can plug the value, I can get the answer. But when to use that, that is what I understand. That's why you need to understand like this diagram. You can able to imagine this. I will not know that value it takes, but I will know that which part is coming at what, where, and I will calculate that part. This is what is more important as a understanding. Okay, so here I can use the law of total probability. How I can use probability of red is equal to probability of red given earn 1 plus probability of red given earn 2. Here given red earn 1, red earn 2. If I calculate this, what will come? 7 by 13 plus 5 by 13 is equal to 12 by 13. Okay. Oh my god.
Yes.
I'm doing something wrong here. Well, it should not be 5 by 13. It should be less, isn't it? Okay, let's see. Because red 1, 2. Okay, let us. I think it should come as 12 by 36, 12 by 26, isn't it? Actually, it should come as 12 by 26. Okay, let's see what we are doing wrong here. Okay, we are having time. So I will show you. Now I want to show you that we can just the formula itself. Whether I want to check that whether the formula which I have given might be wrong also. So I will just check that my mm, mm, Just give me a minute. I'm opening my browser so that I will show you. It will take some few minutes, but then we will clear with Bayes theorem and we will move into the probability theory. So next week, for sure, we will go to the probability distributions, which is a more practical part, or most my favorite part also in probability, which is more fundamental. Okay, or someone of you can search the formula of law of total probability. What is law of total probability? Can you search, Amit or Sajab?
Yeah.
My computer is not cooperating with me. Got it?
1 second, भैया.
You are also in connectivity issue. Unfortunately, I'm not able to even see the message also. Can you please read out for me?
Okay. Probability of A is equal to probability of A divided by B, and probability of into probability of B plus probability of
Okay, sorry. Now am I audible?
yes.
Yeah.
Yes. So what we are, thanks Amit. So what we are doing wrong was, we are taking only probability of A intersection B. Sorry, A given B. It is actually A intersection B. So A intersection B, just now we saw here, what is A intersection B? Probability of A given B into probability of B. So that part we were not doing here. So if we calculate that, it will be around probability of B. So on 1, here it will be 7 by 13 into 1 by 2 plus 5 by 13 into 1 by 2. Correct? So it will come around 3.5 plus 2.5 is equal to 6 by 13. So now it is correct because it is 12 by 26. This is how we were expecting that it will come 12 by 26. So it will come, I will write 12 by 26. 6 by 13 is equal to 12 by 26. So you'll get the answer as 7 by 26 divided by 12 by 26, which is equal to 7 divided by 12. मेरे पीछे नहीं चला गया ना? Will I mark myself?
Understood, भैया.
समझ आ गया? पजल आ गया? Amit,
हाँ जी.
Amit, you got my point?
हाँ भैया.
अगली बार तुझसे एग्जांपल सॉल्व करके लूंगा. Okay?
नक्की नक्की.
Yes, yes. नहीं ठीक है.
भैया,
Yes, yes, ask.
according to this, one example we solved na addiction, that
Hmm.
example, that question,
Ah,
that also will change.
yes. So that time you were right, isn't it? It will come. That's why it was not coming. Yes, yes, yes. You were correct. It should come the 42 here, isn't it? But I was saying that it will be more than 0.5. So here we were doing the same problem. So we means I was doing the same mistake. That probability of B I was not concluding, which is 1 by 6 here, and here probability of B it is 1 by 4. And if we do that part, it will again go to the 3 part, 5 part. So it will eventually it will come to the 0.42 only. Okay, so pardon me for that, my mistake. So it is, so I will just for all of us our understanding, I will write the formula for law of total probability, which is probability of A is equal to probability of A given Bi into probability of Bi. Okay, and I will go from 1 to n. So I told you last time also that event A, B, C, D, instead of we say that event B1, B2, B3, B4. So Maharashtra will be B1, West Bengal will be B2. So this all B2, B1 will calculate. So that I will again plug these values here. So given probability of female is equal to probability of female, we are asking what is person addicted. So probability of addicted is equal to addicted given female into probability of female plus probability of uh, addicted given what male. Yes, male into probability of male. This is what part I have missed, probability of. So you please remember that. So probability of A given addicted given female will come around, and I don't know, now my brain stopped working. I don't know why. But if you do this calculation, it should come eventually to the 0.42. We are missing this part here, which you need to remember. We are almost running half an hour extra, but yes, today it was fruitful. Just before we stop, I'll just take your 1 minute. That now we will move to the probability distributions. So for that, you just recall while next session, the preparation will be like, just recall, no need to worry, or just search about the what is the PMF. Okay, we will see that if you remember last time we said that PMF, it is probability mass function, correct?
Yeah.
It is nothing but probability distribution, but we don't call it probability distribution because for uh, continuous variable it is PDF, probability density function. In this here we will not see this because it requires you to know some kind of calculus. So integral calculus you will need how to integrate, and in general we are not using that much also. We will just only see one of the most important and most celebrated uh, continuous function, which is normal distribution, that we will see later on. But next session we will see some discrete distributions, mainly uniform, Bernoulli, and if we get time, we will see the Poisson distribution
Poison.
also. Yes, yes, yes. Excellent. So Amit is now advanced learner. Huh? Okay, nice. I got Poisson distribution is also nice distribution. So that we will see in next week. Okay. So good night. Keep practicing and stay safe and happy. Okay. Any question?
Thank you. Good.
Yeah, yeah. Actually, I want to No, means I know for in intersection we have to multiply, in union we have to add.
Yes.
But conceptually, I want to know.
See, I'm saying that A and B. Whenever I'm saying and, yes, you need to multiply. Whenever I'm saying A
Yeah.
or B, you need to plus, add. Why? Because if you see diagrammatically, anytime in probability, it is better you draw diagrams. This is A. What I'm saying, event A, last time example, we will take 2, 4, 6, even number. 3 and 6 divisible by 3, and 1 and 5 are empty. What I'm saying that event A and B should happen. So which part I'm taking? This part. Very small part. And how it will come? If I divided probability of A into probability of B, that is going to be give me the probability of, not here I'm saying that, what we are mostly using in this Bernoulli distribution. What we will say that the first toss is tail, second toss is also tail, third toss is also tail. So tail and tail and tail, what is probability of this tail? Which is equal to 1 by 2 into 1 by 2 into 1 by 2 is equal to 1 by 8.
8.
Okay, but I say first toss should be tail or second toss should be tail. In that case, what are my possible outcomes? TT, T, and what is this?
Head.
Head. Okay, sorry, I forgot head. So head, HT, HT, and so 3 are only going to be. So in that case, it is going to be addition of this probability, which is equal to 1 by uh, 2. What is my probability of this part and this part? So we'll see this later on, but what I'm going to see, this is total going to be 3 by 4 is equal to 0.75. Because these are many outcome are going to come. You just remember, and means multiplication, or means addition. When I'm saying or, A or B, so A or B will add A and B also. So both here, if someone is coming, that will come into the my or part. Okay.
Okay.
Anything else?
No, bhai.
And this and or, again, if we have not gone much into the permutation combination problems, but if you solve any problems which are mostly like this, I draw this T T T H H S T T. So this kind of problem will come in case of permutation combinations. How many how many way you can construct, either first will be T or second will be T. So this is what the problem of permutation combination, because here I am taking only 2. If I toss a coin for 10 times, now you can understand the pain to write this T H H T T 2 T T, that becomes just mess. So in that case, you can use the permutation combination formula. So there you need to use and or conditions properly. And here also it is important though. Okay. Anything else?
No, bhai.
Okay. So thanks. Happy to learn with you. I also got learnings today. So we will meet next week with more detailed focus on the probability distribution. Okay. See, I will tell you one thing, that whether you are doing these calculations properly or not, if you are not getting, no problem. You need to understand this, which rule I need to use. Then you can go and search on the internet, use the rule. What happens? You have Excel, you have Python, you have SPSS. It is ready to you to do the calculation. Whatever calculations you want to do, you can plug it and it will do for you. What you need to do, you need to tell that which operation you need to do, whether I need to multiply or whether I need to divide. Just in this case, I forgot the formula. That things are going to happen. So whether I need to use law of total probability or not, in that law of total probability, if I forget to multiply by some event, then it is going to give me the problems. So that's why conceptual understanding you keep in your mind. Once you have the conceptual understanding, you can do it at any way. Okay, so this is what I also focusing for the probability distribution. Once you get the idea of probability distributions, you can do the wonders. Okay, so now I really stop
Okay.
because it is almost half an hour extra. I'm also tired. Okay, good night. Bye. We will meet in next week. Bye.
Yeah, good night, Rama. Bye.
Good night.